Hi guys, so today I'm going to be talking about my presentation about empirical and molecular formulas. I'll start with the definition of each. So the molecular formula is the number and the type of atoms that are in a single molecule of that substance, and the empirical formula can be described as the simplest formula, which is the most reduced ratio of elements that are found in a compound. So some steps for learning and solving these formulas. For the molecular formula, it's pretty easy when you're shown the structural formula of a compound. You can just count each element, then when you write them out, you'll put the element symbol and then the subscript of how many there are. For the empirical formula, it's easiest to write it as a fraction if you can, and then ask yourself if you can take a number out to reduce it. So for example, in slide 4 of my PowerPoint, we have a structural formula consisting of carbon and hydrogen. And you can count that there are 4 carbon and 8 hydrogen, so the molecular formula is simply C4H8. The ratio is 4 carbon for 8 hydrogen, and the largest number you can divide both by is 4. So when you do this, you get 1 carbon to 2 hydrogen, so you would just write CH2. Some things to remember. First of all, sometimes there will be more than 2 atoms, which means you can't write it as a fraction. So for example, we have C5H10O5. It's still easy though because you can see you can take out a 5 and then the empirical formula becomes CH2O. Also, if the ratio of atoms in a molecular formula can't be simplified, the empirical formula will be the same. So for like the compound P3N5, you don't have a common number, so the empirical formula will also be P3N5. Another thing to remember is that many different compounds can have different molecular formulas, but the same empirical formulas, and I listed some examples right here. The key to learning them is just to practice a lot of different compounds. So on slide 7, I have 4 different examples for you guys to try. The first one has 4 carbon, 2 oxygen, and 8 hydrogen, so the molecular formula is C4O2H8. And then you can see you can divide everything by 2 so that the empirical formula, which is the simplest ratio, would become C2OH4. The next one, ethane, has 2 carbon and 6 hydrogen, again dividing everything by 2 to get CH3. Propane is 3 carbon and 8 hydrogen, so this is an example where you don't have a common number, so the empirical formula will read the same. And ethanol has 2 carbon, 6 hydrogen, and 1 oxygen for C2H6O. Again, you don't have anything to divide by, so it will read the same. I put a couple more examples on slide 10, like the compound acetic acid and ethyl alcohol with a structural formula. I won't talk through these examples, but I'll have the answers on the next slide. So here are the answers for acetic acid and ethyl alcohol. And I think the last thing I'm going to talk about is the key takeaways. So the key takeaways are that the empirical formula gives the smallest whole number ratio between elements in a compound, and the molecular formula gives the whole actual number ratio between elements in a compound. And for some molecules, the empirical formula will be the same as the molecular formula. So that's my whole presentation. Thank you guys for listening, and I hope you learned something.